Okay, so now it's time for our next speaker, and I'm going to change language to English, and we're going to depthen the discussion about the materials further. Next speaker is a part of the non-profit organization Material Cultures that reform. Next speaker is a part of the non-profit organization Material Culture that advocates material reforms in construction. Though through design, research, and education, material culture seeks to demonstrate the positive social, ecological, and economical impact of a generative approach that is based on natural materials and low embodied carbon construction technology. I'm very happy to present to you today Summer Islam. Welcome to the stage.
Am I double mic'd?
It works.
Is it working?
Yeah, it's perfect.
Fantastic. It's very high tech. Hi. Hi everyone. Yeah, my name's Summer, and thank you very much for having me today. I'm really excited to share our work with you. So I work at Material Cultures. We're, as has already been said, a not-for-profit. We work between research and design and education, and through our work we look to advocate for material reform in the construction industry. We also argue for the reintegration of architecture and agriculture, seeing landscapes as being irrevocably linked to the extraction or cultivation of materials. We design buildings in our work, and we work in these projects to integrate bio-based materials, particularly in ways which we think are efficient, using systems of prefabrication. We promote the reuse of existing buildings wherever possible, and explore the way of retrofitting buildings using bio-based materials to insulate them, and where possible doing this as economically as we can. We also carry out research, thinking strategically about how these ideas could be applied at scale as we move towards the circular economy, but also more regenerative land management practices. We try to work laterally across different scales, so working on large-scale housing developments and prototypes, down to the kind of one-to-one and the built fragment. And we do this sort of hands-on work, either as part of our own research or working with our students, looking into the relationship between materials and eco-regions. And we also teach across different institutions. We teach architecture, but increasingly we're broadening our kind of remit within education into construction skills, and for this we set up a platform called Make, and through Make we're trying to increase the access to an understanding of how to work with natural materials. We recently published a book called Material Reform, which I'll be talking about later on today downstairs. So I'm going to talk about our work now through three different types of landscapes: through the farmland, principally through design, through forests and thinking about research, and through the wetland, thinking about imagination and education. So we work a lot with straw. It's very good. It's a stem of cereal crops. It's very versatile, and it sequesters about 42% of its matter as carbon. So when you leave it in the field or use it for bedding or burn it, the carbon dioxide is obviously returned back to the atmosphere. But by taking plant matter from our fields and using it in buildings, and using it to substitute the other materials which we have come to think of as the status quo, plant-based buildings can be thought of as kind of carbon batteries. Applying this logic to house building, our research in Yorkshire showed how substituting readily available plant-based construction materials in a standard developer house could turn each individual house from being a net producer of greenhouse gases to a carbon negative unit of storage. We also looked at the amount of land required to grow these materials, and we found that it was fractional, particularly in the context of how much of our land is already dedicated to farming. But the potential economic gains to a region like this, particularly this was Yorkshire in the northeast, which struggles with unemployment, was in the billions of pounds. But underlying this agricultural production is a story about how oil and oil-dependent industrial agriculture has desertified our rural landscapes, poisoned our soils and waterways, and also destroyed our natural habitats. We see this in the biodiversity loss associated with material extraction, which is surprisingly mostly actually attributed to farming. So today we're dependent on a handful of cultivars which support our food systems, which leaves them vulnerable to climate change and pests and disease. So in order for architecture to address not just the climate crisis, but also the biodiversity crisis, if we're going to move towards bio-based construction, we also need to be moving towards regenerative forms of agriculture. So our work is increasingly taking landscape regeneration as a starting point to think about the design of a building. We've been learning from farms like this one in Suffolk. They grow in alleyways, so they have rich verges alongside the edges of the crops, and they cultivate population species of grain and diversify and bring resilience to the ecological system by doing that. A parallel story could also be told about the impact of oil on architecture and the loss of vernacular practices that were inherently low carbon and low impact and bioregional. Essentially, the way we used to work was about gathering up what you had around you, and that has now been substituted by a system where we draw from global, very energy-heavy supply chains. Contemporary construction materials like steel and reinforced concrete align with the patriarchal masculinity of modernism. They are hard, they are immutable, they are easy to count, and they have the illusion of not needing any care. And inversely, perhaps part of the reason that natural materials became to be denigrated is that they align with the feminine, they are soft and mutable, and they are inviting of careful maintenance and repair. Natural materials perform in ways that are attuned to human occupation. They have inherent richness, they breathe, and they contain compounds that are antifungal or antimicrobial. And the history of vernacular architecture is a history of thousands of years of technological development, of research, of testing, of regionally and climatically specific adaptation to material systems. But much of this material technology has already been lost, and the knowledge that remains is in the hands of very few people. So rebuilding a relationship to repair also requires human investment and different sets of relationships to place and territory and the formation of new cultures. Oops. At a project of ours called the Wolves Lane Community Food Growing Centre in North London, we've been working on 2 new buildings for the southern portion of the site. They're kind of grey roofed at the bottom of that image. And they're intended to provide space for learning, working, gathering and distributing food. For the project, we've developed a very simple system, which is lightweight timber frame with straw infill, and we're working with bales, which are taken directly from the fields. The buildings are very roughly rendered in lime, which is pigmented by brick dust, and they're roofed with simple lightweight agricultural steel cladding that slips down the elevations to create a hat. The straw bales are very deep, so they create reveals, and we alternate the glazing in these reveals, making places to sit inside and also outside the building. And the buildings, the way they're configured, forms a series of courtyards, moving from more public facing to more private, depending on the operations of the food growing community. Our contractor on the project, Work Limited, took our 3D model of the building and developed a digital twin, detailing down to the fixings, every single plumbing junction, all of the kind of conduit for the wiring, which meant that they could order everything with extraordinary precision. And for us, it was an exciting kind of transgression, really, bringing the straw bale into the digital world and trying to work with it in contemporary ways. The buildings were designed to be a tool for learning and communicating the value of plant-based materials. And the project is rooted in principles of social justice, creating spaces to practice and grow and learn for historically marginalised communities in London. Places like Wolves Lane are increasingly important as places from which to build community, knowledge, enterprise and leadership. And we developed for the project a participatory construction framework of apprenticeships and skills courses and volunteer sessions. So the building's been host to all sorts of forms of learning all the way through its construction. Direct contact with and understanding of materials and what they feel like is at the heart of material cultures and how we design and how we build. On a small farm in Cambridgeshire, our client Steve Barron established an organisation called Margent Farm. And there he looked at growing hemp for use in experimental biocomposites and alternatives to plastics. He commissioned us to do a project called Flat House, which is a hemp-based flat pack demonstrator house that could show the versatility of hemp. The building takes the form of the existing steel barn that was on the site, retaining part of the structure to support a glazed hothouse and a climbing frame for plants. So a new crop of hemp was sown. And then the harvested plant, which has extraordinary benefits for soil because they have very deep tap roots, was then kind of transported around the UK, unfortunately. So it went first to Yorkshire to be separated, the fibre from the stem of the plant, and then it went to Buckinghamshire where it was combined with lime and cast into panels in the form of hempcrete. And we developed the system with Will Stanix and Oscar Cooper, and the building was erected by our long-term collaborator Henry Stringer. Alongside this work of putting hempcrete inside the building, a cladding material was developed specially for the project, which combines the fibre from the hemp plant with a sugar-based bioresin to make a corrugated rain screen cladding, which looks obviously very much like the one that you see across most agricultural buildings. And then inside, the spaces shift between scales, so working between highly intimate ones and large and open and kind of spacious kind of living space. And working with natural materials in a direct way allows for the materials to be used to hold the space and to give it character. And in designing, I think we have to admit we constantly navigate the compromises and contradictions of working within highly complex and industrialised supply chains. And for this, it's important for us that you see this in the building and the material choices we make are evident. More recently, we've been working to try and scale up the principles in Flat House and on an ex-industrial site in Sussex on the south coast of the UK. We've been working with a developer called Human Nature to deliver part of a 700-home mixed-use development. We've been contributing to the broader material and construction strategy, but also developing the design for 70 homes, which form a dense urban configuration and arrange to create shared courtyards along pedestrianised streets. The unit typologies are varied and designed to be generous, but are both mostly based on the principles of the kind of traditional terraced house that you find across the UK. And we think the project demonstrates what's possible once you start working at a larger scale, presenting the opportunity for building a genuine alliance between sectors, working directly with foresters and farmers to establish supply chains. Large-scale developments are critical to producing scales of efficiency that reduce the cost of materials, but can also fast-track supply chain development. So moving into the forest. For our structures, we look to timber, and then to the woodlands in which trees are grown. Woodlands are a critical habitat for biodiversity and ecosystem restoration, but they're also intertwined with a history, in the UK particularly, of our common lands, particularly those that we have lost access to. We used to be able to source multiple materials from woodlands, which generated different income streams. But today, most of the woodlands we have are privately owned. We have limited access to them, and they're actually in very poor ecological health. So converting agricultural land to woodland is increasingly talked of, but it can also be seen as the beginning of offshoring deforestation. So the plantation development in one place leads to deforestation and carbon costs elsewhere. So there's a critical relationship really between farming and deforestation, but also woodland creation. And as we advocate for change in the way we build, it's important to remember the increasing tensions in how we use our land. And so with the critical role that timber is going to play in the decarbonisation of the global economy, the question of how the demand for wood is met is really critical. And today we think that most of it will be met by engineered timber products which are made from softwoods. So softwoods are generally grown in monoculture plantations like these. They deplete soils, they have very limited biodiversity in their understory, and because they're monocultures, they have no resilience in the face of climate change. Our research has been looking at what our landscapes would look like if we designed our forests, but also our forestry practices around the needs of soil rather than the needs of industry, and then consequently what kind of building culture would emerge from that. So we were working at the Design Museum in London as design ecosystem fellows, and there we worked on this project called Mosaic Landscapes, looking at the opportunities for more resilient treescapes and woodland systems to be paired alongside regenerative land management practices. We were speculating really on a future land use model, a mosaic alternative to monoculture systems, in which maybe arable land is woven alongside short rotation forestry, or quick-growing coppiced hazel, willow and shelter belts of broadleaf tree species. Our research has been exploring how to work with the materials you get from these more diverse forms of treescape. And we published all this work online. It's open source. It can be accessed from our website. And we take this research to the institution where we work with our students, and we've collaborated on the production of prototypical and experimental building structures, thinking about the materials that grow in our woodlands today, but also speculating on the ones that might grow in our woodlands in the future, like this prototype here, which is actually made with eucalyptus timber, which is increasingly being grown in the UK for biomass. Alternative treescape models will be lower yield, but in a sustainable future, the construction industry needs to adapt to these landscape systems. So whilst we look to grow more diverse treescapes, we also need to better manage the ones that we have, make sure they're in good condition. And so although we acknowledge and we advocate that the principles of working with bio-based materials are very good, we think it's buildings like this now which we need to question, because evidence suggests that as the supply and demand for engineered timber grows, the global biodiversity declines at a proportionate rate. And we have very scarce forestry resources, so we need to be thinking about how to use them as efficiently as possible. One of our earliest projects, which centred timber supply chains, was called Plank House. It was a 3-storey self-built home, and it was designed by one of our earlier practices called practice architecture, in very close collaboration with the client. As a self-build, the project is in many ways still ongoing. It's a story of homeowner agency, of continued care and maintenance and renewal. It's a monolithic 3-storey timber and hempcrete building, and it has a textiles workshop and 2 apartments in it, and a raised external courtyard. It's very flexible and can operate as a series of interdependent or independent units. In this project, we cast the hempcrete in situ, so you get shuttered board lift lines like you do with fair-face concrete, but much warmer and softer. The design approach in this project was intended to use carbon sequestering materials in ways which used simple and robust detailing to maximum effect. So actually the frame, the floors, the skirting boards, the whole project was made with one single section of Douglas fir timber of the same size, which is all sourced from one mill in Salisbury. And we oversized the sections to allow for charring, so we didn't need to use intermescent coatings to protect the building from fire. And because the section size is so large, we had a very wide portal frame, about 1.2 metre column centres, and then the floorboard spanned about 1 metre. But then ultimately that means the primary materials perform multiple functions. So they act structurally, but they also provide acoustic insulation, thermal insulation, fire resistance between floors. And so we needed to use less alternate materials. We have, for example, no soffit. And the building celebrates the materials from which it's made, giving it a richness of character. And that the primary materials are close at hand also means that it's easy to adapt them, to maintain them, and to rework them. And equally, because it's so simple to put together, it's simple to take apart. And whilst we found that actually there are quite good supply chains for timber around the south of the UK, around London, on this project we've been working on more recently in the Isle of Bute in Scotland, the conditions for milling and sourcing timber are very different, although actually Scotland holds most of the UK's timber stocks. Bute itself is now entirely a farming landscape. It used to have a very precious temperate ecosystem, a rainforest on most of the island, but you can see just about what's left of it is the kind of shadow on the northern corner of the island. We've been working on a site which is surrounded fully by industrial farming to refurbish an old steading building which has been left derelict for decades, the steading being the kind of vernacular farm typology that you get in this area. When we started the project, the first thing we had to do was take off the existing timber structure. The slates that were on the roof had fallen in and the timber was rotting. What this left us with was a series of very wet stone walls, which are actually quite hard to work with if you're trying to introduce bio-based materials. The first thing we had to do was to dry them out fully so that they could then be line rendered again to protect them from the elements, because it's very close to the sea. Ultimately, the plan that we've been working with is very simple, creating 2 independent dwellings, keeping some of the stone rooms unroofed as kind of gardens, which are appendages to the house, making spaces that are sheltered from the very strong offshore winds. We worked with a landscape architect called Jane L. Gibbons, who've designed the landscape around the house using the temperate rainforest plants that are native to the island. And the porch is a series of timber columns, which carry kind of oversized slate eaves. We lifted the eastern wing of the building to introduce a new mirrored gable, which gives the kitchen and the living room very generous head height. And where we can, we're working with the existing stone on site to rebuild the walls. This has been an incredibly slow process, I have to say. Very interesting, but very slow. We have an excellent building surveyor. He's called Kinley Laidlaw, and his understanding of historic buildings and the consideration of how the work is planned has extended to visiting all the beaches on the island to find the exact beach where the shells come from that were used to make the original lime mortars, which is the traditional process that was used before. But also he works to plan how the masonry work happens on site, which has been really kind of important learning for us, so that the work for the masons isn't repetitive or dull. So he breaks up the tasks and does a plan of work, which means that you cycle through alternate tasks rather than doing all the dressing in one day. Our roofer, Hector Whitelaw, has been reusing the old slates to rebuild a new roof. And where we've been bringing in new materials, we use wood fibre insulation, wood wall boards, and clay plasters. Much like the many aristocratic estates across the UK, the private woodlands of the estate of the Marquis of Bute, so the kind of landed gentry of the island, are standing still today, not because they're native ecosystems, but quite the opposite. They are kind of a portrait of a colonial history, and they host a series of cultivated specimen trees. We've been working with the estate managers on the island. There's one sawmill trying to resist the pull to import from the mainland from much further away the timber to build a new roof. There is a plantation woodland on the island as well. There's also storm-managed felling, but most of the plantation woodland is actually used for firewood. And they have a very small management team at the mill. They're very nice, very sweet and very friendly, but they have no in-house structural grading capacity. This is a portrait of what milling is like in the UK, actually. It's been fully centralised into large mills that are quite far apart. So for this project, our engineer trained specifically in the capacity to visually grade the timber so that we could work with the trees that were nearby. But on a small island like Bute, it's massively depleted in its industry and population. It has a population of about 7,000 people. Supporting the kind of growing industries is a critical way of moving towards more sustainable supply chains. But as I've said, it involves very complex processes which are, I guess, without the support from policy, they are very expensive. But it also involves us thinking differently about the role of the architect in the future. And finally, I'm just going to talk very quickly. My last forest project is one we've been working on in Yorkshire for a long time with the Forestry Commission and Forestry England. Working with a group of students from Central St Martin's School of Architecture with 30 master's students to think about the construction process of a timber building as a pedagogic tool. And in this project, we've been thinking specifically about the limitations of British forestry. So we've designed a building which works with 2 species of timber, with ash and larch, which are today essentially affected by pandemics, exacerbated by global warming. And in this project, we've used ash and larch, which are, you can see them in green and orange, to think about how you mix timber species in a structure, not just as a whole, but even with within a single structural component. And then working within the limits of what you can actually grow within British woodland. So we actually just have shorter trees, shorter lengths of timber section. And then the project as a whole is a kind of portrait of things that we make today from our woodlands, from British woodlands in Europe, but many materials which we don't make in the UK, like wood fibre insulation, but could, with a kind of growing manufacturing base, we could be making them ourselves. The project was prefabricated in very small workshops in London by a team of about 15 students, and then it was dry fit in our contractors' workshops in Yorkshire called Yorkshire Oak, and it's ready to be erected on site in about 2 weeks. And then the final landscape I'm going to talk about today is the wetland, because we've recently started looking at wetlands as a landscape of potential, and also a site for imagination and a kind of, I guess, a springboard for conversations about what a future regenerative landscape might look like. So swamps, marshes, fens and wetlands were historically identified as kind of areas of mystery, places of threat. They were wastelands, and they were articulated as places which had no inherent benefit to human populations. They are obviously critical ecosystems, they're stopovers for migrating birds, they're carbon sinks, and they're buffers against sea flooding. But they were considered to be kind of landscapes of untamed nature that needed to be transformed into farming landscape, essentially. Productive grain fields that could be controlled. So what you see on this map is a historic map of the fens in eastern England, which were wet and nutrient-rich and diverse. And this is the same area which was drained and turned into grain fields. Civilizing a swamp was essentially to drain it, to dry it out. And walking around now, moving through these landscapes, it's very hard to understand that they were ever wetlands at all. A common misconception is that early settlement or civilization started in arid settings, which we then irrigated to grow crops. But actually, human civilizations first settled in wetlands. They have very little written records because everything was perishable, and it was an oral culture. Equally, the building materials perished, and so there's not a wealth of archaeological record about this. Ultimately, those civilizations have been claimed by water and soil and time, and until recently, this has remained invisible. What is exciting about this form of settlement, and also, I guess for us, why it's become a central conversation in the practice, is that they were resistant to centralization and control from above. So there was no single dominant resource which could be monopolized or controlled from the center. States didn't begin in wetlands. There were societies based on common property resources. Everyone had access to plants and creatures and birds. And we think, although it sounds glib, these ecologies kind of enable us to think beyond the sort of binary notion of wet and dry. So the project we worked on recently was in the Cernitz lowlands in Brandenburg in Germany, where, like across much of Europe, the land was drained to access the peat soils for farming. But in order to protect the biodiversity in these landscapes and the carbon that's been slowly stored in the peat, increasing projects are looking to re-wet the landscape, which is essentially to allow it to flood again. We do this through human intervention, like blocking drains and ditches. Excitingly, they also release beavers again, allowing them to do what they know how to do best, so they build dams, and the water table comes up again. Because it's important to think that when we flood a wetland, ultimately the agricultural practices over the last decades have to be replaced, and so there are communities there who've been working and their livelihoods are being threatened by these processes. But there's a lot of potential in re-wetting and rewilding wetlands for conservation and production. And what's important critically in the wetland is you can have a coexistence of landscape regeneration and biodiversity restoration, material production and food production. So where there was vegetable growing and grazing animals, now there are farmed water buffalo who are quite happy to live in a wetland and have the right kind of feet. And we've been working with an organisation called Bauhaus Earth to look at how reeds and other paludiculture crops from these landscapes could be cultivated to the benefit of the farmer, but also of the landscape. So we've been working with manufacturers and farmers and conservationists to understand how this supply chain could grow and scale. By looking at the volumes of materials that could be sustainably harvested from the site, we also began to understand the potential for a material supply chain that could feed both retrofit and new build. So very simply, we quantify the amount of materials you need to make a new house or to retrofit an old one under the German building regulations using materials that could be harvested from our site. And on sites like ours, which is 80 hectares, if you leave 10% fully to biodiversity, and the rest is sustainably harvested, you could essentially grow 60 houses a year. We've been exploring the potential of wetlands through different narratives, through ways of organising, methods of production, in the office, but also in the academic research we do with our students. This teaching is really integral to our practice. we learn as much as we hope our students learn with us. We enable students to make buildings, we work a one-to-one, and we design regenerative building systems together. This fragment that you see here is a one-to-one that was produced by some of our students at the ETH last year. And it's like an entire housing system made basically with bulrush or cattail and reed, and timbers that grow, or using timber from trees that grow in and near wetlands. We work in groups to understand the materials we're working with and how they perform, but also how to build with them. And with these skills, we build these fragments, particularly thinking about the kind of ecological consequences of scaling the materials that we're using. So this prototype here is made using eelgrass as an insulating material. And the focus of our teaching work is not generally programmatic. We develop building systems which could be applied in numerous ways, learning from the land, but also learning from the people who work the land. This system by our students was looking at how to work with prefabrication using water reed cultivated in the UK. I guess the critical reason that we're interested in education is that our industry today doesn't have the skills to use these materials because they're not very well understood and they're not taught. So the construction industry has also not been good for the people who work in it, and how we respect labour and the body is tied to the use of fewer toxic materials. We're interested in uncovering old skills and developing new ones. And through our platform, Make, we've been teaching people how to build with earth and straw, and reed and hempcrete and lime, operating from various construction sites across London and the UK. And together with practitioners and workshop participants, we've been developing a model for a different sort of construction training, one that's more engaging and participatory and reciprocal, because we believe that through experimentation and play, we can develop new material technologies together. We believe that in order to make meaningful change in the construction industry, we sort of have to accept that there aren't any easy answers, and that all construction practices cause harm and all require compromise. But to move forward, we think that architects have to back sources and supply chains and draw on the knowledge and experience we have from different disciplines to incrementally figure out which of the compromises are acceptable and in which the harm outweighs the good. Thank you very much.
Okay, beautiful. Thank you so much, Summer. It was amazing lecture. I think she deserves another applaud. Come on.